Hello everyone, we're bringing to you a chemistry lesson on nitrogen oxide versus nitrogen dioxide versus nitrous oxide. This presentation is brought to you by Natalia Pinto, Skylar Guerrero, and Ornella Morenzi. Nitric oxide. Nitric oxide is a colorized toxic gas that is formed by the oxidation of nitrogen. The level structure of nitric oxide is made of a nitrogen atom and an oxygen atom. Both atoms are connected by a double bond. The nitrogen atom has one pair of unpaired electrons, while the oxygen atom has two pairs of unpaired electrons. Next is the formal charge. The formal charge of nitrogen is 5 minus 3 plus 2, which gives 0. 6 minus 4 plus 2, which gives 0. The resonance structure, we can notice the placement of both double bonds and single bonds vary. The double bonds on oxygen can either be on the top or be on the right, which also goes for the single bonds. Nitric oxide. Nitric oxide has a stability which is relatively unstable. Its molecular geometry is linear. Its polarity is polar. The nitric oxide does not follow the octet rule. Some of the hazardous qualities of nitric oxide is acid toxicity, inhalation, oxidation gases, skin corrosion, and irritation. To go into more depth about the previous slide, we're going to talk about the coloration of physical and chemical properties of nitrogen oxide. The stability defines by dynamic molecules of pressures and free unpaired electrons. The molecule can gain and lose electrons from the ions of nitrogen minus or nitrogen plus. The molecular geometry of nitrogen oxide reacts with transition metals to give the complexes called metal nitrosyls. The most common bonding mode of nitric oxide is a terminal linear type. Rule violation. Nitric oxide violates the octet rule, which is because nitrogen has a free radical unpaired electron. The polarity of nitrogen oxide is to the right of oxygen and in the periodic table. Nitrogen is less electronegative oxygen. All NO bonds are polar and more electrodensity of oxygen atoms.
Nitrogen dioxide. NO2 is a reddish-brown gas that decomposes in water to form nitric acid and nitric oxide. The other threshold for recognition of NO2 in air is 0.1 to 0.4 parts per million. Most individuals become tolerant or desynthesize the other as exposure direction is increased. The lowest structure, NO2, is composed by a nitrogen atom with a single electron on top, and it will also have a double bond with an oxygen. This oxygen will contain two pairs of electrons, and then the nitrogen will have another oxygen hold to it, but with a single bond, and this oxygen will have three lone pairs of electrons. Okay, let's take a look at the formal charges of nitrogen dioxide. The formal charge of nitrogen will be 1. The formal charge of oxygen and the double bond will be 0. And the formal charge of oxygen and the single bond will be -1. So if we add this together, it will give you a total formal charge of 0. If we start talking about the resonance structure, we can notice that the double bonds and the single bonds will interchange each other of positions. So the double bond could be on the right or to the left of the nitrogen, and the single bond could be to the right or to the left of the nitrogen. Let's learn more about nitrogen dioxide and the correlation of physical and chemical properties of this model. If we look into the rule violation, this molecule does not obey the after rule. In nitrogen dioxide, each oxygen atom contributes 6 valence electrons, and the nitrogen atoms contribute 5 with a total of 17. This results in nitrogen dioxide disobeying the after rule. If we take a look at its polarity, you will find out that it's a polar molecule. This is due to the different electronegativity components. Oxygen have a very strong electronegativity. If we look at its stability, we will find out that it's a stable molecule. Due to its resistance to react during chemical reactions because of the strong bonds and the electronegativity component that we just talked about. And if we take a look at the molecular geometry, taking a look at this diagram over here, we'll decide that it's a trigonal planar. And this is due to its 3 shared bonds. If we take a look at the hazard qualities of NO2, we will realize that it has an acute toxicity, inhalation is really dangerous, its hazardous for aquatic environments, is chronic, and oxidized gases. It can cause a skin corrosion or irritation too.
Now let's take a look at nitrous oxide, N2O. It is a colorless gas with a sweetish odor prepared by heating ammonium nitrate. It produces exhilaration or anesthesia when inhaled and is used as an anesthetic and as an aerosol propellant. Its Lewis structure is a nitrogen atom as its center atom, with to its right a single bond connecting it to an oxygen atom that has 2 pairs of unpaired electrons. To its left, we have another nitrogen atom connected by a triple bond with 1 pair of an unpaired electron. Now let's take a look at the formal charge and resonance structure of nitrous oxide. The left nitrogen in nitrous oxide has a formal charge of 0. The central nitrogen has a formal charge of +1, and the oxygen has a formal charge of -1. This brings the total formal charge of nitrous oxide to be +2. Now let's take a look at the resonance structures of nitrous oxide. As we can see, the bonds and the unpaired electrons can change places in between the resonance structures, but what can never change is the number of electrons in the molecule. In this case, it is 16. In the first resonance structure, we see that the left nitrogen has a triple bond and 1 pair of unpaired electrons. The oxygen has a single bond and 3 pairs of unpaired electrons. Now looking at the second resonance structure, there's a double bond on either side of the central nitrogen, with the left nitrogen now having 2 unpaired electrons, and the right oxygen having 2 pairs of unpaired electrons as well. Looking at the last structure, we see that there is a single bond to the left of the central nitrogen, with the left nitrogen having 3 pairs of unpaired electrons. To the right, we see that the oxygen has a double bond and 1 pair of unpaired electrons. If you take a close look, you can see that in each structure, there is still only 16 electrons in the molecule. Now let's take a look at the rule violation, molecular geometry, polarity, and stability of nitrous oxide. And with these, we will give the correlation of physical and chemical properties. Rule violation. Nitrous oxide has none. It does not violate the octet rule. The molecular geometry of nitrous oxide is linear, with a bond angle of 180 degrees. This is due to the center nitrogen having 0 lone pair of electrons. Polarity. The polarity of nitrous oxide is polar, but not strong. Despite its strong electronegativity, the negative formal charge is concentrated on the terminal nitrogen, and the sharing of electrons is unequal. Stability. It is a very stable molecule, and rather inert chemically at room temperatures. Due to its strong bonds and electronegative properties, the rate of decomposition is very slow, making the molecule stable.
Its hazard qualities are acute toxicity, oral, organic peroxide, and self-reactive substances and mixtures. Now let's compare and contrast the properties within nitric oxide, nitrogen dioxide, and nitrous oxide. In nitric oxide, we see that its stability is relatively unstable, but nitrogen dioxide and nitrous oxide are both stable. With the polarity, we see that nitric oxide is polar, nitrogen dioxide is also polar, and nitrous oxide is polar, but it's poorly polar. Molecular geometry, nitric oxide is linear, nitrogen dioxide is trigonoplanar, and nitrous oxide is linear as well. Nitric oxide's rule violation is yes, nitrogen dioxide is also yes, but nitrous oxide is no. Thank you for listening to our chemistry lesson on nitric oxide, nitrogen dioxide, and nitrous oxide. My partners Natalia Pinto and Ornella Morenzi and I were happy to present these molecules to you. Thank you.